Pre-calculus students, welcome to today's notes. This is lesson 9.1. We're going to focus in on circles only today. There is more to 9.1 we'll get to later, dealing with parabolas, but today we're going to focus on circles. These notes should be fairly short. You've seen these before. I'm going to let you guys do some of the reading on this first page. You can see the definition of a circle and then the standard form. There are times when that center is at the origin. In that case, you can use the simpler version of the formula, but most of the time we're going to be looking at circles where the center is away from the origin. So we're going to be using x minus h squared plus y minus k squared equals r squared. So keep that formula in mind. That one right there, we're going to be using it quite a lot. All right, so here we go. First problem, find the standard form for the circle with center 3, -7 that passes through the point 0, 4. One thing I should point out, when we do our circular formula, x minus h quantity squared plus y minus k squared equals r squared, really what we're doing is the distance formula. Think about it for a minute. If you take the square root of both sides, square root, all of a sudden this left side now looks a whole lot like distance formula that you used back in the geometry days and perhaps even prior to that. And there's a reason for that being the distance formula. It's because that's all a circle is. It's a set distance from a point. So we can use the equation for a circle or we can use the distance formula, but the truth is they're kind of the same thing. All right, so when we use the circular formula, we're going to have the essentially the change in y, so that would be 4 minus -7 or 4 plus 7 squared. We'll have our change in x, that's going to be 0 minus 3, again squared. So my radius squared is going to be 121 plus 9, so 130. Now, we could find the radius, but the reality is, when we're using the equation of a circle, we really don't exactly care about the radius. We care about the radius squared. We have all we need. So again, the center is right here at 3, -7. So we're going to have x minus 3 quantity squared plus y plus 7 squared equals the radius squared, which in this case is 130. There's your circular equation. All right, moving on to number 2, and you may note that on your notes you don't have this nice, lovely grid, but it's all right. You'll figure it out. You can just sketch it, or you can grab some graph paper, your call. All right, so we're going to sketch the circle given by this function here and identify the center and radius for the circle. Maybe equation would be the better word rather than function, but we'll roll with it. So here's what we're going to do. All these terms, like we have an x squared and an x, we have a y squared and a 4y, those aren't the way we graph circles. We need it to be, x minus h squared. So we're going to do this little thing called completing the square. Okay, so I got x squared minus 2x. I'm going to think of those terms together. I'm going to do half of 2, and I'm going to square it. And I'll get that on the other side too in just a moment. And then over here we're going to have the y terms grouped, y squared minus 4y. I need to add half of 4 and square that. And then we had this minus 4 out here at the end. I'm just going to move it to the other side. Also, I need to finish completing the square process by doing plus 1 and plus 4. That balances my equation. All right, so the first one, x minus 1 squared plus y minus 2 quantity squared equals 9. Okay, now this problem says to identify the center and radius. It also says to sketch, but it kind of makes sense to do the center and radius first, I think. So our center, we can see it, it's h and k, so it's 1 and 2. The radius would be the square root of 9, or just simply 3. So the way to graph this, I think you know this part of it. Go mark your center, and then we will probably the easiest way actually would be to mark the points to the right, the left, the top, and the bottom, each being 3 units away. And then we can sketch our circle. I'm pretty good at drawing circles by hand, as you can see. And there it is. And now for the final problem on today's notes, number 3. We're going to find the x and y intercepts of the graph of the circle given by the equation. Now we could, use technology. It's a little tricky to graph those on your TI-84s, but you can do it with, a little practice. You can graph them on Desmos pretty easily. And we could approximate values, but we want to find the exact x and y intercepts. So here's how we're going to do that. We have to think about, well, what does an x-intercept mean? Well, an x-intercept means that my y value is 0. So to find the x-intercepts, I'm simply going to plug in 0 for y. So I'm going to have x plus 2 quantity squared plus negative 1 squared. I went ahead and just plugged in 0 for y equal to 10. All right, let's start solving this thing. So x plus 2 squared is going to equal 9 once we subtract that 1 from each side. And if I take the square root and subtract 2, I'm going to get x is equal to negative 2 plus or minus 3 for my x-intercepts. All right, let's go through the same process for the y-intercepts. Again, the y-intercept is defined as anywhere our x value is equal to 0. X is 0, so I'm going to have 2 squared plus y minus 1 squared equals 10. And we'll go about solving that. So if I subtract 4 from each side, I'll get 6. This one's not going to be the nice perfect square that we had on the last one, but we're okay with that. So y is equal to 1 plus or minus the square root of 6. All right, let's go ahead and list these in a little bit cleaner fashion. So my x-intercepts, negative 2 plus 3, that would be 1 and 0. Negative 2 minus 3 would be negative 5 and 0. And it's maybe debatable if you need to split these others. I think I'm just going to keep them together and do 0 and 1 plus or minus the square root of 6. Folks, I think that was pretty painless. You've managed to make it to the end of your 9-1 Circles Notes video. Have a spectacular day, and we'll see you soon.